Hello and welcome. My name is Dr. Powell, and I'm going to talk to you about a type of puzzle which I call a Sumobius puzzle. I call this type of diagram that you see here a Sumobius picture. Notice that it's made up of vertices and arrows. At each vertex, there are two numbers, a higher number and a lower number. The lower number is simply a sum. It's a sum of the higher numbers that occur at the vertices up to and including this point. So for instance, see this 8, it's a sum of 4 and 4. This 13 right here is a sum of 5, 4, and 4. That's because these guys are below this. There's a path that comes from this vertex up to this one. Now, this 16 is the sum of 0, 3, 5, 4, and 4, since there's paths from all these vertices up to this one. And this 19 right here is a sum of 3, 5, 3, 4, and 4. A Sumobius puzzle is the task of creating such a picture if all you had was a list of these higher numbers and a list of the lower numbers. For instance, suppose that we have a list of higher numbers, which we will just call nodes, and a list of lower numbers, which we will call sums. And we want to kind of create a picture. So let's work through a way that we might be able to do this. Now, I'll go through this fairly quickly, knowing the end from the beginning in this case, but in general, you would have to work through such a reasoning process to find out what the picture is going to look like. Okay, so I just kind of write out the nodes, right, like this. And these sums right here are simply going to be groupings of these nodes, but we got to do this in the right way so we can actually make a picture like that. Strategy might be, well, first of all, the nodes that are at the way bottom are only going to have one node, and that's going to be the sum. Notice you see a 4 and a 6. This 4 might come from just saying 4 here, grouping that. And then we have something at the bottom. So the node is 4 and the sum up to that point is 4. Now we could think maybe 6 could be obtained by going 4 and then having a node of 2 up here. And we could try that. And perhaps there's a way of going about it in that direction. So there's some trial and error as we go along. But from foreknowledge, I know that this is a good option if we just circle the 6 and we think of that as being its own vertex right here. Okay, now how do we go from here? Now, every time we make a group, we need to include previously circled groups, because things that come from other places, plus just one more node, because we just want one number appearing there. So what if we just did this? We circled what we already had plus one new guy. This 2 plus 4 plus 6 would be 12. Notice we've just crossed out that much. So we could say 2, and the sum up to that point is 12. So we have the beginning of a Sumobius picture. Okay, now let's see, how could we get maybe this 14? We could take the grouping of 4 and 6 and then just have one new thing that hasn't been grouped yet. See this 4, and that would make, so we could go 4 and 6, and that would go up to adding on 4 for a total sum up to this point of 14. Okay, what about this 13? We could just do, well, 7 hasn't been used yet. We could just go 6 to 7 like that. That would work. So just a single arrow from 6 going up to 7 for a total sum of 13 to that point. Well, okay, we need to get this 18. How do we get this? Well, looking at this, we see 4, 6, 7, and 1 would give it to us. And that actually would be good because this 4 is its own group and 6 and 7 is its own group. So we could circle those plus this 1. Looks good. That would give us 18. Let's see how that would work. So that means we would go start from that 4 and see the 6 and 7. We could get both of those just by having an arrow, a single arrow that comes up like this for a node of 1 that we add on to the 17 to give us 18. We could have an arrow going from here to here as well, but it's unnecessary since 6 will be below if we just have this arrow coming from this mark here at 7. So we have just created a Sumobius picture to finish out and complete our Sumobius puzzle. Thank you for watching.